Hi all, today let's see how we can build and publish an Angular library as an npm package into the Azure DevOps Artifacts. So here we have an ADO repository called Anrup Joy, and here we have a master branch. So I have also created a separate branch called beta from this particular master, and I have cloned the code in my local system, which I have opened here in the VS Code. So here, this is a normal Angular application with one addition, that there is a library which has been created called the core lib. So I have previously done a video explaining how we can create Angular libraries. So if you have not seen it, please watch it. So now the main thing we want to do is we will be building this particular core lib and then publishing it as an npm package. So for that, first let us create a Azure pipeline YAML file. So this video is basically a continuation from my previous video, which explains how we can create a pipeline to build and deploy Angular applications. So if you have not seen it, please watch it. So as explained earlier, here we have defined the YAML file, and the first statement is the trigger, which means that this particular pipeline, which is created from this YAML, it needs to be triggered whenever a check-in happens into the master. So after that, here we are making use of multi-stage YAML pipeline. So this is the first stage, that is the build. And here we are defining the pool, which is the agent pool. And we are saying that it should be taking the Windows latest, that is the image, the virtual machine image for our agent. So after that, we define the jobs which need to be run as part of this build stage. And here we have the initial job called build, and the display name we have given it as Angular library build. And initially we are cleaning up the workspace, which deletes all the temporary files or the files which have been checked out during the previous run of our pipeline. So once we have done that, we are defining the steps which need to be executed. And the first task is that we need to install the Node.js. So for that, we make use of the Node tool, and we specify the version of the node, that is 16.x. So once it is installed, we are doing an npm install so that all the dependencies of our project gets installed within the node modules. So once the npm install is completed, we will be building our application. So in this scenario, we are building only the library because we need to publish the library to our npm. So here, while running the command, so we are making use of the custom npm command. And if you go to the package.json, we have the script build. So it basically is ng build. And here, the difference between the previous video and the current video is that here we are actually passing a parameter called core lib, which is the target name for our library. So here we will be running the command npm run build core lib, and which in turn will run the command ng build core lib. So once our library is built, we are also running the test as well as the lint for our library. So once these steps are completed, a dist folder will be created within which there will be a folder called core lib. So within our next step, what we are saying is that here in our application, we have a file called npmrc. So it is basically a configuration file which is used by our npm. So here we can define the registry. So before going into details of this, let's go to our Azure DevOps. So here we have seen that within the file tab, we are able to see our branch and all the codes. So coming down, we have a section called artifacts. So Once I click on the artifact, here we have the different npm artifacts or npm feeds which are getting displayed here. So in order to create a new feed, you can click on the create feed button and you can specify a name, and here you need to select the visibility. So here for the already created artifact, that is the npm packages, I had selected the first option, which will provide visibility to all the members of the Active Directory. And here we have an option called upstream sources. So the main concept of upstream source is that our application may depend on many npm packages that come from the public npm registry, that is the npmjs.com. So in order to get all these public sources, we can check this option so that when we create our own registry, so this is the registry which I have created from the npm artifacts, that is the ADO artifacts which we saw earlier, and the feed is npm packages. So once we select this option, what happens is that all these public packages, that is, for example, like the Angular, all those dependencies which needs to come from npm.js, they will also be available within our artifact or the feed. So I have selected that. Now here we have the option to either define the scope. So either we can select the project level scope or at the organization level. So it is recommended to make use of the project scope. So we can select that, and once we give the name, we can just create it. So once we have created the feed, this is the view which we will be able to see. So here the different feeds which are available will be listed, and the project scope feeds as well as the organization scope feeds will be available. So here we are making use of the npm packages, which is the project scope feed for our demo. So in order to get the URL which we saw here, that is the registry URL for our particular feed, what we need to do is that we need to connect to feed. So here there are multiple options which are available. So since we are interested only in the npm, we can click on npm, and here we will be able to get the registry link as well as this option which says that we always need to authenticate. So just copy this content and create a file called .npmrc, paste the content which we saw here, and the significance of this is that once we create this file, whenever we do an npm install, it will be referring this particular registry instead of the actual public registry which we saw earlier. So here is when the upstream sources comes into picture. So since we are pointing to this particular feed for all the npm packages, the upstream will mirror all the public packages also within our npm registry. So once we have created this npmrc, we can use the same npmrc for publishing our custom package, that is the core lib, to the Azure artifact. So what needs to be done is that when we build our library, that's a core lib, a folder will be created called core lib. So once it is created, we need to copy this npmrc to within this library folder, that is the dist/core lib. So once we do that, when we execute the command called npm publish, it automatically publishes this library or the contents of this folder to this particular artifact feed. This is the main use of npmrc file. So within our YAML, the pipeline YAML, we are defining this process that we need to copy the npmrc file from within the root folder to this dist/core lib. So once we do that, again, these steps are similar to what we previously did for building our application or publishing our application. So we create the build.artifact staging directory /dist, and once we have done that, we copy the contents of this core lib to within that dist folder. So this is the main use of this copy dist content script. So once we have done that, what we do is that we can publish this content, the contents of this folder, to the pipeline artifact. So it's basically a cloud storage, so that once we publish these contents, we will be able to download these contents within our next stage. So as you see here, this is our build stage. So our next stage will be the publish stage, where we will be actually publishing the npm package. For that, we are temporarily storing our build output. So once we give the target of our build output and define the artifact name and also the artifact type. So here we have defined it as pipeline, since this is a part of the pipeline build, and we can give the name of our step as well. So now let's do one thing. Let's check in the code. So once the code is checked in, we can go to the pipeline section, and now let's create a new pipeline that is based on the Azure Git repo. And since our code is lying within the Android repository, we can select that and select the existing Azure Pipelines YAML file. And our branch is beta. And here we can define the path of our YAML file. So once we do that, we will be able to see our YAML file, which we went through earlier. Now we can save this. The newly created pipeline will be listed in the old section. We can just rename it now. So here I am naming it as Angular library deploy, and I'm going to save it. So let's run this pipeline from the beta branch and see what happens. So our pipeline has initialized. So it is making use of the Windows latest image, and it has started executing our steps. So this is our initial stage, that is the build stage. And inside that we have the job Angular library build. So now you can see that actually our npm install step has failed. So it is saying that this particular package is not found within our npm feed, that is this registry. So let's check that. So this is the library name, Babel generator. So let's go to our artifact. So here you can see that there are different sources which are listed here. So as I previously mentioned, these are the upstream sources. So when we select npm.js, we will be able to see all the packages which have been taken from the npm.js upstream. So here when we search for Babel generator, so here you can see that even though the Babel generator is present actually within our registry, the problem is that the version number is not matching. So in order to avoid all these issues which can happen with our upstreams, what we can do is that we can provide the npmrc. So let's go to the npmrc. So here we will be able to provide multiple registries which can be defined at a scope. So scope basically means that if you go to our core lib, we have the package.json. So here our library name is core lib. So the problem with this approach is that there can be a library with the same name, that is core lib, which is present within our public npm registry. So in order to avoid such namespace conflict, what we can do is that we can provide our own namespace. So here I am going to give a namespace or scope as it is called, so that this particular namespace will be unique for our packages. So you will be familiar with such namespaces in existing applications as well. So here if we go, you can see that the Angular packages, all of them share a single scope called @Angular. So here we can also define a similar scope, and inside the npmrc we can point each of these scopes to one particular registry URL. So here I am saying that the framework, the JS framework scope that needs to point to our artifact feed, and all the other packages can actually take from within the npm public registry. So here I am giving the npm public registry. So this means that all the packages which have the namespace or scope JS framework, it will be taken from our npm registry, and all the remaining packages will be taken from the public registry. So once we have made these changes, let us check in the code. And let's run our pipeline. So now you can see that once we have made the changes within our npmrc, that is adding both the registries, our npm install is successful, and all the remaining steps, that is the build of the library, the unit testing for our library, the linting for our library, all these are completed successfully. Now once it is completed, we are copying the contents of our core lib, that is a disk core lib, to the artifact staging directory, and then we are publishing it. So to verify that the contents of the dist folder has been published, we can go back here, and here you can see the one published item, and the artifact name is given as drop, as we had mentioned within our pipeline. So within that we will be able to see the contents of our build folder, that is the build output of our library. Since we have successfully completed the build stage of our pipeline, the only thing that is pending is that we need to publish the output of our library build folder to the npm registry. So one problem with this particular approach which we followed now is that here we have the package version of our library. So each time a change is made, actually we need to manually go to this particular file, that is the package.json within our core lib, and we need to increment our versions, the version of a npm package. So it has a particular format. So as you can see, this format is called the semantic versioning, and the significance of each of this digit is that this is a major version, this is a minor version, and the third one is the patch version. So whenever any non-breaking changes are made to a library, we need to increment the patch version. Whenever there is a change in any of the interface, but it is not a huge change, but still it can break the application. So in that kind of scenarios, we need to update the minor version, that is the second option. And in case there is a huge change, like for example, when a new version of Angular is released, like the Angular 12 to Angular 13, they will be incrementing the major version. So these are the three versions that are available in a package version, which they call the semantic versioning. There are options in which we can automatically generate these semantic versions by making use of some packages. So let's see how we can do that so that we can avoid making these changes manually each time we publish the changes. So here within our package.json, I have added two dependencies, that is the semantic release, that is an npm package, as well as the semantic release ADO, which is a plugin for using the semantic release within our ADO pipelines. So the semantic release, basically what it does is that it consists of many plugins which will be analyzing our commit messages. So commit messages are basically what we give here whenever we do a commit to our particular branch. We can type the messages that represent the changes we have done. So we can give anything here, but for generating this semantic versioning, what we can do is that we can define some predefined formats for this commit messages so that this particular plugin, that is the semantic release commit analyzer, it will be analyzing our commit messages and based on the format. So we have a preset called Angular. So before that, we need to have a release.rc.json file that needs to be defined, which will contain the configuration for our semantic release library. So here it makes use of multiple plugins here. So one of the plugin, as I mentioned, is the commit analyzer. So based on the commit message which we define here, so we have the preset as Angular. So the standard format is that in case we start our commit message with a fixed colon, then what happens is that the semantic release library automatically increments the patch version of our library. Similarly, when we start with a feat option, which represents a new feature, it will increment the minor version of our library. Similarly, in case any commit message consists of these statements, that is a breaking change or breaking changes, it will automatically increment the major version of our library. This is the method through which the commit analyzer, it will analyze our commits and decide which version of or which part of our version needs to be incremented. Similarly, here also we can define the branches on which this particular analysis needs to be done. So here I have defined that in case of master as well as this particular branch, that is the beta branch. So usually the semantic versioning is done on the master branch because we need not increment the package versions when we create new packages or when we publish the packages on a development branch. But there can be scenarios where we need to publish some pre-release versions of our package. So for doing that, we can make use of the beta, and here once we enable this flag, that is pre-release true, what happens is that whatever is the name of our branch, that is beta, in this scenario it is beta. So if you give anything else, it will append that particular branch name to the package version which will be generated. So these are the two things that we need to keep in mind. And here we have the second plugin, that is the semantic release ADO, which is used basically for integrating the semantic release within our YAML pipeline on the ADO. So now going to our YAML pipeline, I have made some changes. So let's go through that. So the first thing is that I am running the command npx semantic release. Basically, we are trying to execute the semantic release tool so that it will perform all the actions like analyzing the commits, incrementing the version of our packages, and everything. And here we are giving the access token so that actually the semantic release will be creating a particular tag for each of the versions that are getting generated. So in order to create the tags, it needs to authenticate the GitHub token. So we are providing the system access token here so that our pipeline will be able to do that. And once we have done everything, here a variable is generated called the next release. So this is actually done by our this plugin, that is the Semantic-release ADO plugin. So this variable basically contains the next version of our package which is being generated by this pipeline. What happens is that here we make use of a task called file transform, and we are saying that within the core lib all the target files, that is the package.json. So here actually we need to modify the version of our package.json. So we are basically saying that whatever comes as output of next release, that particular content needs to be overwritten on the version field of our package. So that part we are defining here. So here we are saying that variable section, the version part of our target files need to be replaced with our next release variable. So once we have done that, automatically this pipeline will be updating the version and publishing it to our npm registry, that is our ADO artifact. So the developer need not worry about manually incrementing the version of our packages and checking in every time. So this is the main advantage of using the semantic versioning. Now let's see this in action. So here I am going to check in these changes, and here I am giving the commit message as fix semantic release. Now I am committing this. So since we are committing that in the beta branch, we will be creating a pre-release as we defined here. And since it is a fix, we will be bumping up the patch part of our version. So now let's run the pipeline, running it from the beta branch. So our pipeline has completed execution, and let us see the extra steps we have added. So this is the semantic release step which we added. So here we can see that the commit analyzer is analyzing each of the commits within our branch, and in case it matches with the fixed version, it is saying that the release type for this is patch, and all the other commits which do not match this particular pattern, it will not generate a release. So as of now there are 3 commits, and it decides that the output will be a patch release. Now what it does is that it will create the next version of our package, that is it decides that the next version is 1.0.0 beta.2. Since this is a pre-release, this is the package, this is the patch version, and here it will be updating, and also it will be creating a tag. For the semantic release to function properly, it needs to have some permissions. So for giving that, in the project settings, in the repository, our particular repository, go to the security tab, and here we will have our user agent, which will be usually this format, that is the project name, the build service, and our organization name, and click on that. Here the pipeline needs to have the contribute access as allow, and also the manage nodes permission also it should be allowed. So once these two are allowed, our pipeline will be able to execute the npm release and also create the tag. Now in the next show version, we are echoing the next version, and within our replace token step, within the package.json, it is actually replacing the version value with the new version. So once everything is done, it will publish our artifacts, and here we can check in the published artifact whether the version has been updated. So here I am clicking on the package.json. So it has been downloaded, and here you can see that the version key is matching the new version which has been generated. So also here, if we go to our repos, the tags, here you will be able to see the new tag which has been generated. So this is how the semantic release will be keeping track of the new version to be generated. So whenever we do a commit, it will analyze the commit and it will check what was the previous version from the tags, and based on the tag as well as the new commit, it will generate the new version. So now the final step that is remaining within our library pipeline is that we need to publish the output of our build. So here I have added the second stage, that is a publish, and I am saying that it depends on the build stage and the build stage should be successfully completed. Also, I am giving the pool and the agent details, and within the job section, I am giving the job details. So here again, I am cleaning the workspace, and the first step that we are doing is that we are downloading the pipeline artifact which we had previously published in the build stage. So here I am giving the source, that is current, artifact, the same artifact name which we gave here, and the path which will be the workspace /drop. So from there it will automatically download our artifact, and once we have done that, what I am doing is that I am making use of the npm authenticate tool, so that whatever registries which we have defined within our npmrc, the token will be generated for all these registries and it will be stored, so that our pipeline will be able to access or authenticate these registries. So since the npm JS.org is a public registry, it does not require authentication, but for the private registries, it will be generating a token. And once it has authenticated, next our pipeline will be trying to publish the npm package. So for that, we make use of the npm task and run the command publish. Also, we say that the working directory is the build directory /drop, which we have downloaded here. And also we say that the publish registry, it needs to make use of a feed, that is our artifact feed which we have created here, that is npm packages. And the publish feed, we are giving it as, since it is a project scope, we need to give the name of the project, that is Andrewjoy / the feed name. So once we have done this, let's make a commit, and here I am again giving it as a fix and adding the comment as publish. So now once we run our pipeline, a new package should be ideally created within our artifact feed. So I am selecting the beta branch and running the pipeline. So our pipeline has completed execution, and as you can see, the publish stage of the pipeline has also completed, and we have the publish npm package, that's a job name. Here again we are checking out the code and the download pipeline artifact, which will download the published artifact from the previous stage. And in the npm authenticate, we add the credentials for our npm registry. And finally, we publish our npm package to our artifact feed. So here you can see the version of our package, that is beta 3. And finally, if you go to our artifact, here from the source we have this feed. So here if you check, you can see our new package, that is JS framework /corelib, and the current version is shown here, that is beta 3. So now finally let us create a absolute version, that is the stable version without any pre-release tags. So for that, let's create a pull request. So I am creating a pull request from beta to the master branch, and here I am giving the initial version commit message. I am creating the pull request, approving it, and I'm going to complete it. So here one thing to note is that whenever we merge a pull request, the actual comment which we provided here. So here you can see that actually I mentioned it is like fix colon initial version, but here you can see that it automatically adds something before this commit message. Since our commit analyzer, that is the semantic release, depends on this particular message, actually this addition of this prefix will defeat the purpose of the commit analyzer. So for that we need to do some modifications within our release RC JSON. So here what we can do is that we can add these custom release rules. So here what we are saying is that in the header tag, whenever these kind of messages are coming, that is the merged PR along with a number, and in case there is a fix or feature, in case of a fix it will be a patch release, and in case of feature it will be a minor release. For the major, it does not depend on the commit message, it depends on the commit footer, so it does not have any impact. So since we have already added this within our release RC JSON, when we complete the merge, our pipeline should be automatically started. So here you can see that since the trigger was provided, our pipeline has started automatically. So the pipeline which was triggered from the PR merge, it has been completed. And if you go to our artifacts, you can see that a major version of our core lib has been released, that is the 1.0.0. Since it is from the master branch, it will not have any pre-release tags. So now what we can do is that since we have published this npm package within the artifact, we will be able to consume this library within another application. So here I have another Angular 13 application in which I need to consume this package. So for that, what we need to do is that first we need to add the library as a dependency within our package.json. Once we have done that, we need to create the npmrc file, which should be same as whatever we created in the other repository. So we have the scoped registry, which is the local, and the public npm registry. Now once we have done that, we can refer the code from within the library. So if we go to our library, you can see the core lib module, which is being referenced here within the imports, and we will be able to access the declarations, that is the lib core lib, here within our consumer application. So first let's npm install the dependency. So the dependency have been installed, and now you can see that actually we are able to consume the library. So in case we are running the npm install for the first time, we need to do an additional step here. So we need to run this step, that is we need to install a global package, npm package called vsts npm auth, and once we have done that, we need to run this command vsts npm auth -config give the .npmrc. So this is similar to our npm authenticate module which we saw within our pipeline, but this command needs to be run only in the local for the developer. So once this command is run, it will add the necessary personal access token locally, so that we will be able to authenticate to the local registry. So once we have done that, we can do an npm install. So here I have done that. Now let's create the pipeline for our consumer application. So this is exactly similar to what we created in our previous video. So here I am creating the pipeline and I am naming it as Angular app deploy. So this basically we will be deploying to our static web page that is in Azure container. So here I have created the pipeline. Now let's run it and see. So here we need to link the variable groups. So this I have explained in my previous video. So our pipeline has started running. So here our consumer pipeline has completed. So our application has been deployed. So previously it was not existing. Now when I refresh the page, you can see that our application is deployed and the core library is also consumed here. So previously you had seen that in the consuming application, I had given the exact version of our dependency. So here I have given 1.0.0. So one problem with this approach is that whenever the library version changes, we need to manually go to the consuming application and modify it. So in order to avoid that, there are a few syntaxes. So one is this symbol. So it means that it will take all the patch versions up to 1.1. So in case the latest version is 1.0.5, it will be taking that version. So there's another symbol that is the cap symbol, which means that it will take all the versions of this library until the next major version. So in case our library version is 1.2.0, that's the latest, then it will be taking that as the version, but it won't take any 2 point versions. So here in our example, what I am going to do is that I have added the cap so that all patch and minor versions will automatically be updated in the consuming applications. So now let's see how we can link both the pipelines. So whenever a change happens in the library, we need to publish the library as well as run our consuming application so that the latest version of our library will be downloaded and installed, and then that application will be deployed in the Azure. So let's do one thing. Here I have a change to my library code. So in order to link both our pipelines, what we can do is that this is our app deploy pipeline. So here we have the triggers. There we can add the build completion. So here I am setting up the trigger that whenever the deploy pipeline is completed from the master branch, it needs to trigger our app deploy pipeline. So let's see whether this will happen. So now I am going to approve and complete the pull request for our library, and I am merging it. So let's see what happens. As soon as the pull request is merged, immediately our library pipeline is started. Now let's see whether the app deploy pipeline will be started once this library pipeline is completed. So our npm publish is in progress. So let's see whether our consuming application pipeline is triggered after the build pipeline is completed. So here we are publishing the package. It's completed. Now let's go to our pipelines tab and see. So here you can see that our consuming application pipeline has automatically started. So once this is completed, we will be able to see the changes which we applied in our library automatically. Hope you are able to get a good understanding about how we can build and publish Angular libraries as NPM packages to the Azure DevOps Artifacts. See you soon. Thank you.